Hello guys, I'm going to talk in this video about the relationship between pressure, area and force. And in order to demonstrate that for you, first of all, I'm going to attempt an experiment. I'm not sure how it's going to go, but we'll see if I can manage it. So I'm just going to move that back so you can see what I'm doing. So what I have here is I have a glass and I have just stuck on the top of the glass a film of tissue paper. And what I'm going to be doing is I'm going to be applying force to that tissue paper using two different objects with different areas, and we're going to see what happens. Now, I expect most of you are going to be able to guess before I even start which of these is going to do the job and which one isn't. So I have, first of all, a bundle of sticks which has a large area on the bottom. So I'm going to be putting that large area on my tissue paper and exerting a force. And then I'm going to take a very small area, just one stick, okay, and I'm going to exert that force on the tissue paper as well. And I'm going to attempt to use the same force for both of them. It's going to be difficult for me to do this properly. It's not correct experimental conditions because I'm just doing this from home. So I do apologise to all science teachers out there for the poor quality of this experiment. But in order to attempt to exert an equal force on both of them, I am going to use this collection of coasters that I've stuck together, and I'm going to pop that on top and see if I can hopefully see which of these is going to push through the tissue paper. I expect a lot of you have already guessed which one it is, but I'm going to do it anyway just for fun. So I'm first of all going to take this one with a large area. I'm going to pop it on. Let's see if this works. I'm then, without pushing down with my hand at all, going to just pop the coasters on top, and hopefully you can see there is some force being exerted, but it's not enough to push through the toilet paper when I have a large area. Okay, so next up I've got my small area, very, very small point. I'm going to pop that point on the tissue paper, and then I'm going to be exerting the same force, as close to the same force as I can get, by popping this on top. Whoops, if I can. And I'm not going to put any extra weight on it for my hands, but there you go. Very, very quickly that one went through. So what we can see here is if I take two different objects, I've got a big area and small area, I put them on the same surface, and for one of them it goes through, one of them it doesn't. Same force roughly that I've exerted on the top. This one went through very, very easily because it had a small area. Okay. Okay, so the reason why in my experiment just now, the stick was able to push through and this one with the same force was not, is because the force for this one was all concentrated on a tiny area. So all that force was pushing through that tiny area. Whereas for this one, the force was shared equally across the whole area. So each individual point, if you imagine it, has a little bit less force going through it. Okay, and that's the principle behind pressure. Okay, so I'm just going to give you the maths behind this now. So what we have here is a relationship between pressure, force, and area. And pressure is the force shared equally or divided by the area. Okay, this is the formula: pressure equals force over area. You can, if you prefer to, think of it as a triangle, just like you can for speed, distance, time. Okay, you need to put force on the top, and then you have P and A down there. Okay, so pressure equals force over area. And we also need to be aware of the units as well. Hopefully you're already confident with area being meters squared or centimeters squared. And force we refer to in newtons after Sir Isaac. Okay, so we've got force in newtons, area in square units. Pressure is newtons per area unit. Okay, so newtons per meter square, newtons per centimeter squared. And if we're talking about newtons per meter squared, that also has a special name, pascals. Okay, so we can measure newtons per meter squared. You might see written as PA, number of pascals. Okay, so I'm now going to go through 3 examples of how we can be given 2 facts and find the third one. So we've got one where I'm finding the pressure, one where I'm finding the area, and one where I'm finding the force. If you're already confident with this, feel free to pause the video and either use the triangle or the formula to try and work through the answers on your own. That's absolutely fine. I'm going to go through these with a bit of an explanation. I'm going to use the ratio method, but you can use whichever one works for you. Okay, so looking at the first question, I'm imagining here that I've got something with an area of 4 meters squared, and it's pushing down with a force of 4,800 newtons. So I'm just going to draw a little diagram of this. So here's my area of 4 meters squared, and I could even split it up into 4 meter squares, and I'm pushing down on that whole thing with an overall force of 4,800 newtons. And the question is, what is the pressure? The pressure is, what is the force per meter squared? So newtons per meter squared. So one way of thinking about this is, I've got to share this force evenly between each of the meter squares. So some of you might be able to see just visually from that if I take this 4,800 and I divide it by 4, then each meter squared is going to get the same force going through it. So that's one way of thinking about it. And if you can see that visually, you'll hopefully be able to see that each meter squared is getting 1,200 newtons going through it. So it's 1,200 newtons per meter squared. Two other ways of thinking about it, which I'll just do for this first example. I've got 4,800 newtons for 4 meters squared. Pressure is per 1 meter squared, so I want that to be a 1. So if I divide this by 4, I've got to do the same over here, so 1,200 newtons. So again, 1,200 newtons per meter squared, which I can put here as my answer. Or you can put it into the formula. Okay, so I can say that pressure equals force over area. And if you're going to use the formula, then you can absolutely fine to just plug them in and work it out. But just make sure you notice the units on here and pop that in as your answer as well. Okay. Next one. We've got a pressure and we've got a force and we want an area. So I'm going to have to do this down here now. Okay, so we've got a pressure and we've got a force. So the pressure tells me that 180 newtons is going through each meter squared. And I need a force overall of 540 newtons. So I need to work out what area that's going to need. So you can either think, well, what do I need to times up to get to there? And then do the same over here, thinking about it like a ratio. What we actually need to times here is 3. And you can work that out by doing 540 divided by 180. So I times 3 over here. So I've got 3 meters squared. That's one way of doing it. Or if you prefer the formula method, I've got P equals force over area. So I can put in 180 equals 540 over A, times both sides by A, divide by 180, which comes out as 3 still. Okay, so we've still got our answer of 3 meters squared, whichever method works better for you. Okay, next one, we've got the pressure as 36. So I know that 36 newtons is going through each centimetre squared, because that's the units I've been given here. But I want to know what force is going to go through an area of 30 centimetres squared. So hopefully you can see here with the ratio, I've got to times this side by 30. So I've got to times this side by 30 as well. The way I'm going to do this is by timesing by 3 and then timesing by 10. So 36 times 3, 18, 3 times 3 is 9, plus the 1 is 10. Then I've got to times that by 10. So I think 1,080 newtons is going to be going through all 30 centimetres squared. The other way of doing it is using the formula. So I'm going to move up a little bit more again. So I've got pressure equals force over area. So I can put in my 36 equals force over 30, times both sides by 30, and you can see I'm still doing 36 times 30. Okay, so it's the same sum, same thing goes on, it's just different ways of seeing how it works. Before I finish the video, I just want to go through the rearranging of the formula, because some people prefer the 3 rearrangements to having to manipulate it once they put the numbers in. So we already know that we've got pressure equals force over area. if I times both sides by A, or area, I get pressure times area equals force. Okay, so that's the second version of the formula. Force is pressure times area. And I can also then divide by P on both sides to get A on its own. F divided by P is F over P. So area is force divided by pressure. Okay, so those are the three formulas. Okay, it's exactly the same relationship, but just expressed with a different letter as the subject. And if you prefer to have the three written out rather than manipulate the one, then that's fine. And again, we can also do it using the triangle if you prefer the triangle method. Put force on the top, pressure and area here. So if you want pressure, it's force over area. If you want force, it's pressure times area. And if you want area, it's force over pressure. So you can then work through it. As I say, if you're using the formula or the triangle, just pay attention to the units, okay, and make sure that they're correct for your pressure and they're the same as your force and your area units.